Okay, it looks like we are live. Um, hey everybody, I don't know if we have many people just at this second, but if you are listening, we're trying a new tech setup. So bear with us if anything gets weird. But we're very excited to be resuming the Gatsby Web Creators series today, and I'm going to hand it over to you, Marcy.
Hello, everyone, and welcome to Gatsby Web Creators. We're picking up with a series 2 today. For the next 4 weeks, we are going to be playing around with JavaScript and doing a bit of a path to Gatsby. So Gatsby is a website framework, uses the React JavaScript library. We're going to gradually build up to that over the next 4 weeks, but we're going to do the good kind of weird and play with code and try to create stuff. So we'll always have a sort of task-based outcome for each week where we will create something fun with code. And you can follow along with the series. We have our webpage, gatsbyjs.com/gatsby-web-creators. That's where you can always find the materials for each week's lesson. We'll put the video links up there later on. I am joined by Aisha Blake. Say hi, Aisha.
Hello, how's it going, everybody?
I'm so excited to be back and to have you here. So, Aisha, I wanted to start off with a question of what's your favorite nature phenomenon, if you have anything that comes to mind?
So, the thing that comes to mind first, honestly, is blueberries. My family has a lot of land in upstate New York, and one of my favorite things to do as a kid was to like go out in the field and pick these like wild blueberries.
One for you, one for me, one for the bucket, one for me.
Exactly.
Don't make it out of there with very many in the bucket. That's my memory. Yeah, my favorite nature phenomenon, because I see it all the time when I'm outside, is the golden hour. When the light turns that golden color, happens, around sunrise and in the evenings. It's a really great time to take photographs, and every time it just takes my breath away. So today, we're going to play with JavaScript and make some art that sort of resembles nature. And we're using Glitch as our platform. And there is a link to our final project on the Gatsby website. But I have taken that end project, stripped away the code that we're going to create. So I'm working off of a Scratch file, but you can remix the final project, which on Glitch, there are ways you can see our Gatsby Web Creators team for every project we've worked on. And I have to remember my way around here. So from the top, whenever you're on a Glitch project, there's this little drop down and you can remix a project or create a new one. It's a pretty fun platform we've been using. So I had some inspiration for today. Aisha, did you ever play with a spirograph?
You know, I did when I was a kid. Yeah.
They were these plastic pieces that had these two wheels with teeth on the inside, sort of like gears. And you could use a pen to draw these really intricate designs. And that popped into my head of, wow, that would be really cool to make something like that with JavaScript. And I sort of went down memory lane and watched some videos and started looking into the math involved, which as a creative person, I sort of have a love-hate relationship with math. But this really rekindled my interest, actually. And we maybe won't get quite there for a spirograph today, but we can create something like this rose math. So creating, flowers from lines kind of coming out from circles. And there's some really great YouTube videos if you want to dive deeper into this sort of thing. And I have them linked in the Gatsby project, either the final one or the Scratch file I'm working off of. I have a list of resources here, including a video on kind of the math behind Spirograph. You can follow the same trail that I did to get to where we're going today. There is also this really neat project. It uses JavaScript that is a Spirograph where you can take this gear and draw it around, and it creates these circles, sort of like you would with a pen and the actual Spirograph toy. So this is a pretty neat project and shows you what you could kind of the end result of where we could get to if we had way more time than an hour. That's how long we have today. But the Inspirograph This Spirograph math video actually talks about that project and compares the physical toy with the online version. So that's really interesting. And I found another YouTube channel called The Coding Train that is sort of the basis of what we'll do today to create some mathematical rows patterns. So how are we going to do that? Well, we could write all of this with vanilla JavaScript. So JavaScript that we write entirely by ourselves. It would be tough to get as far in an hour. So I have elected to use a project called P5.js. P5 is a JavaScript library for creative coding. It gives you some JavaScript functions and things for free. They come with this library. So once you've included it in your project, you can do some really neat things. Aisha, have you used P5 before?
So I haven't used P5. So as you know, Marcy, I am starting a very creative tech conference, and it's focused on musical and theatrical performances, but I also have, and sort of naturally have, a lot of very creative developers wanting to be involved. And so a ton of them pointed me to P5 as this like cool tool and community for creative coding. And so that's kind of where my interest comes from.
Neat. Yeah, I mean, thinking of music, which is also pretty mathematical, you could do some really neat visualizations with P5. Really, the possibilities are endless. And so today we'll talk about what P5 is doing so we can sort of like when we include it, which I'm on the Getting Started page on p5js.org. I'm going to go and copy a script tag so that I can link out to P5 in my HTML file. So let's dive right in if we're ready.
Let's do it.
So in our index.html file, I'm going to paste this link to the P5 library. And so it's linking out to it on a CDN or a content delivery network. And so that way it will load this in the page. And now we have P5 here. So I also have a JavaScript file called script.js that's already linked in here. So I'm going to open that file. And just to make sure that this is working, similar to our last session, which was a true intro to JavaScript, we're going to pick up from there and do some more creative stuff. So I could say, hi, Gatsby web creators. And I've got this page with some text over here. If I do, I'm doing control click and inspect on my Mac, I can open up the console and just see that, okay, my script file is attached, it's working. So I can do some things in here. I could also, with the console open, just make sure that P5 is there. So I typed the word P5 and it's returning some code that is included with that library. I could also, let's see, I'm going to hold off on that. I know that P5 is in here. I'm going to come back to the console and do some more inspecting. But the first thing I'm going to do is follow the Getting Started page on p5js.org. So they give you some functions that you have to call for free, including the setup and the draw functions. So for our first sketch, I'm going to copy the code right out of the Getting Started. And I will paste it in here, and voila, I have a circle. It is, so our two functions, I mean, that's pretty easy to start drawing. So I'm amped. We've got setup. So setup, even though this function, we're not putting anything in it necessarily, but P5 needs this function to exist for your code to run. And so there's a couple things that I want to point out here with setup and draw. I have this function signature with the keyword function, then a space, the function name here of setup, the parentheses, which if this function had parameters we could pass in or arguments, then these curly braces denote the scope of this function. And we looked at these functions a little bit in our last session in week 5 when we talked about JavaScript and the document object model. And so here we are using P5, it's looking for these functions and then it calls them behind the scenes. So normally when you write JavaScript, writing a function like this wouldn't do anything on its own. I would have to call setup manually or some other way of invoking that function. But P5 is doing that for us behind the scenes. So a little bit of magic here. And the draw function is really interesting because it is running on an automatic loop. So I could say console.log draw, and if I open up the console again, go straight to console, it's counting. I can see it's logged the word draw, and the count of how many times it's calling is it's always polling. So draw is just happening all the time. I didn't actually have to call it. I just wrote the function, and P5 will run whatever I put inside of this function. So pretty awesome. I want to knock your socks off with the next example out of the P5 getting started. So we can do really neat things with P5, including following the mouse. So in our last session, we talked about events and how whenever you bind an event, like a click event, or you can watch your mouse move using vanilla JavaScript, P5 does some extra stuff behind the scenes to make it so you don't have to call all of that manually. But you can still do really neat things with the mouse. So I pasted this code in here. I am going to just move my mouse over here, and it's so neat. It created an ellipse like we had before, that circle, but the draw function, because it's being called all the time, every time I move my mouse, it's adding a new circle, which is really neat. And I can do things like, so this code, let's look, setup, it says create canvas. And if we go and inspect that, this gets back into our friend HTML, which I'm going to get my developer tools open a little more here. In our HTML, like where we put our script tag, P5, when we call create canvas, is putting a canvas HTML element in here. And canvas is basically a box that you can put in an HTML document, and then you can draw two-dimensionally with JavaScript. It's like pixels that you can draw circles and shapes, and kind of a visualization tool. It's 2D information, so not super accessible to someone using a screen reader. So this is a visual art representation. You can use it for all kinds of things. So we're playing with canvas when we use P5 and its create canvas function. So this code in setup has created a canvas element with the dimensions of 640 pixels wide by 480 high. And you can kind of see that in the web page over here, how the circles have this edge in this corner. That is using those dimensions that I have put in there. And then in the draw function that's polling, you know, every frame or every second, you can adjust how often it runs, but it's looking for this P5 variable called mouse is pressed. So is the mouse doing its thing? So if I click and hold, it actually changes the behavior here with the way this code is written. And then it's running this fill function. So fill of 0 is black. And I can use other values here. Like if I wanted the color keyword name of red, which we've seen color keywords before, I can change this color to use a string value of red. Let's say maybe I wanted blue for the other color. So I can change these colors of what's happening here with P5 by passing in different values. And fill takes different color things. Let's see. So the P5 reference is a really interesting page to visit when you're playing with P5, so you can see what all the options are. Fill, we can go and look at all the different values that it takes. So you can take integer values, so number values that represent colors. In web development, we have different color spaces. So red, green, blue for RGB. We have these named color strings like we talked about. There's this other format that I use a lot as a web developer called Hexadecimal, and it is a color space that has these values. I tend to find them either by playing in the developer tools, and you can copy one. You can get them out of applications like Photoshop or Illustrator, along with a lot of these other color spaces. You don't really need to know all of them right now. Just know that you can pass different values, and starting with these named color values like we've seen before seems to work fine to me. And then we can use the fun names like light green or maroon. Whatever colors we want. Make it ugly, make it pretty, whatever strikes your fancy. So I'm pretty impressed with P5 already. What do you think of it, Aisha?
I think it's super cool. And it makes, for me at least, it makes these really fun, creative things that you can do with code a little more approachable. Because as you mentioned already, there's plenty of math involved, and there are lots of functions and things that you need to know about that you don't necessarily use in your kind of everyday web development. And so it's nice to get this tool that will give you this sort of gentle introduction.
Yeah, I think it really unlocks some possibilities that you're not having to write all of this code behind the scenes. So like draw, calling on every frame, you would have to write that. Stuff with detecting the mouse, you would have to write all of that. I think the flip side, or kind of what can be confusing, is how P5 is giving you this stuff for free. So it does take a little bit of a mental shift to know, okay, which parts are JavaScript itself and which parts are P5. So the syntax here, like function, you can write any custom function you want, but these specific functions of setup and draw, here's one where it's being called directly, fill. So we're not writing out, function space fill and defining our own function. We're calling one from P5. But P5 is giving us these handles for specific functions, or we could call them API methods, so an application programming interface. These API methods from P5, they do give you the opportunity to write your own function body here, and then it calls it automatically. So ellipse is another one from P5. These parameters of mouse X, mouse Y, those are coming from P5. So it's like if you didn't define it, but it's available to you in a P5 script, that means that it's not throwing an error, then it's probably you're getting it from P5. And you can always go look at the reference to know, what is that thing? Like, I would recommend looking at a lot of the examples, and you can find examples of all kinds of things, even some 3D neat stuff, but you can go inspect any one of these examples. And because that draw method is always running, you can use it for animation. But you can go and look at any of these methods that are being called in here, like push or translate, rotate. And by looking at the reference, go back here, you can sort of compare an example to the reference and see which functions are being called and what are the options I can pass to it, like giving a background color or moving it from, if you think of a space like our canvas, go back and look at this canvas, it's got, 640 pixels wide by 480 high. Think of that like a map. It's sort of like Cartesian coordinates, or a map where it's got X and Y. And so if you have a point on the canvas, if you translate it, you're moving something to a different point on that canvas. So it's pretty literal. Like you have, so many pixels, and if you want to plot something on a canvas, you have to place it in that specific spot. So that's where translate comes in.
I think this is a good point to make about really any kind of abstraction. You have to balance the relative ease of use that you get, the speed in development that you get when you use a tool like this, but you balance that with knowing kind of what parts are coming from that abstraction, from that tool that you're using to make your life easier. Also, we do have a question, but first, Lori on Tech points out that this would make a mean caterpillar.
Oh, yes. I want to make it green. Yeah. And you could even, maybe the shape that you create on Mouse X, you could give it eyes or something. That would be pretty neat.
Totally.
Yeah. What was the question?
We got a question from Cobweb39. Is P5 a lightweight library?
Ooh, good question. As far as I know, yes. So let's see, how do I want to verify that? I mean, I can go and look at the developer tools and see kind of the weight of this thing. So opening my my developer tools in Chrome, which is the browser I'm using, I can go over to this sources tab and see. So Glitch has a lot of its own stuff. So that's sort of, because we're working on Glitch, all of its resources are being loaded in the web page. But I believe my project here is in this iframe, so the week 6 Scratch file, and I can go and look at what's being included here. And here is P5 coming from the content delivery network. So I think you can go really deep into profiling of your JavaScript stuff. In terms of weight of this thing, I would have to go and look. So unless anyone has a quick suggestion to verify file weight without me having to download it and look locally.
Yeah, would you get that from the network tab?
Oh yeah, maybe the network tab. And I can look at just JavaScript. I refreshed the page to see it pull down all of the resources that are coming from Glitch. We are in an iframe, so that might make it a little tricky. But that is typically how you could look at the file size. So here, for files that are being downloaded, 5.5 kilobytes for P5. Yeah, we'll have to look. I guess what I could do is open this project in a browser.
Oh, true.
And I've got this little change URL thing. I can go and open this in a new tab. So this is my little project. Oh, and here, when I have it in a bigger tab, you can see that 640 by 480 canvas size, because you can see the edges of it in this bigger window. But I could go over to the network tab and refresh this again. It is 636 kilobytes. So it is pretty sizable. There might be a minified version or something that's a little smaller. So you do, like Aisha was saying, with trade-offs, with abstraction. So an abstraction is a piece of code that we're using to abstract away a lot of the details. So we don't have to implement those ourselves. But sometimes that trade-off means that you're having to download a file to play with. So you have to decide, like, what is this for? Is it for playing and learning how to code? Maybe that trade-off of having code that you had to download is fine. But if you're building a production-ready website, maybe you don't need a whole library, and it does make sense to write some of the code yourself.
Yeah.
All right. So, and if there are any other questions, feel free to shout them out. I would like to start working on some of this rows math and playing with P5.
Let's do it.
Okay, so we know we need our setup function. And I'm going to change this canvas size to be a little smaller. Let's do 400 by 400. We'll make this a square. And so that is going to create a canvas just like we had before, but a little bit smaller. And in our, in our draw function, we need to create some circles, but we're actually going to be using some more math than we've seen before. And I am not claiming to be a mathematician. I did not write all of this myself, but it's really piqued my interest to get back into math and some trigonometry, which, in high school, I really struggled with. And I think no matter what time in life, like, I'm excited about math after this. So I hope you will be too. And if you have some math knowledge or questions, feel free to add them in the chat. But we're gonna barrel through and try to create something cool. So in this draw function, I need to append some stuff here. And so the first thing I'm gonna do is kind of create the sequence of code for the draw function to go and do on a loop. I am going to start by putting a background. So the background, every time this draws, I'm going to fill it with, I'll give it this white color variable. You can also, a shorthand for the white color is 255, which you can really nerd out on color spaces like we saw on the P5 reference. I'll leave this as white just for, you know, understandability while we're working through this. We also talked about translate and how with these Cartesian coordinates, you know, it's X and Y. P5 will start off by putting things in the top left corner. So to have a piece of art that's centered in our 400 by 400 canvas, I'm going to start by translating the width divided by 2, so half the width, and then the height divided by 2. And so that way, anything I append will, instead of starting in the top left corner, like we saw with our caterpillar mouse friend, we will have this artwork append in the middle. And this is sort of a good programming trick all the time, like this width divided by 2, height divided by 2. I've used that for CSS positioning, making carousels, and like all kinds of things. So that's a pretty portable piece of knowledge that you can get this dynamic width. This is coming from P5, but there's other ways to calculate width with JavaScript, but it's always that, you know, divided by 2 gets you the halfway point. We're going to call a P5 function called begin shape. And so we're going to use, instead of points, we'll be using vertices. And then that, you know, depends on a beginning of a shape and an end of a shape to actually close those lines. This sort of makes me think of Adobe Illustrator, which is a application I use to make vector artwork. So artwork that's based on math instead of pixels. Like a lot of images have pixel values. If they're made with math like this, they can scale, they can, you know, look really sharp no matter what size of a monitor you have. And you can do some pretty neat mathy things with these vertices and shapes. I'm going to give this a stroke. So whatever we draw will actually have a visible line. And I could give it black to start. We'll play with colors a little bit later on. I'm going to give it a stroke weight of 1. These are all P5 functions that are in that reference page. And now we need to start looping. So, I mean, I could start by doing a vertex of, let's say, like 25 by 50, just to create something on here. And then I need to do end shape and pass this P5 close thing. I'm not actually seeing anything yet. So I think, you know, you need multiple vertices to actually see something. So maybe if I did multiple, I'm just playing around here. Let's see if I can get anything. Oh, something happened. So I have 2 vertices, you know, I have points that can connect. And if these go in some sort of a predictable pattern, we can actually start making these shapes. So even though draw is running continuously, and we saw that in the console, how it was logging something. So this is polling for changes. So if I add another loop in here, so in JavaScript, I can use what's called a for loop. And I think we saw one in our last session. So I'm going to say for let a equals 0. So I'm starting at 0. I'm going to increment. I'm basically taking this a from 0 up to a certain number. So I'm going to say, well, during the condition that a is less than 2 underscore pi, this is what's called a constant. It's from P5. And so pi is, you know, the point from, or the amount of distance from the center of a circle to its edge. 2 pi is essentially double that ratio. And so P5 has these variables or constants, which are things that never change, and you can use them in your formulas. And I'm going to increment a by an arbitrary value of 0.05. And you can play with different values here. I'm going to use only one call to this vertex function. And I was hard coding numbers in here, but we're actually going to get the numbers from our loop that we're calling. And I'm going to do a trick here to space these out a little bit with our loop. I'm going to multiply this by 8. And that is a bit of an arbitrary number too. And arbitrary just meaning like you can change it, you can play with it. It's there just to, you know, make it stylistically how I want, but you can play with other values. So now here's where the mathy part comes in. And I can start by saying let r for radius equals, I'm going to do the cosine of a variable that I haven't defined yet. Let's see, let's just pick a number. Let's do like 30, and I'm going to multiply it by a, which is the variable that we are incrementing through this loop. And so r needs to feed into our x and y coordinates. So I'm going to say let x, and x is going to be moving every time we go through this loop. So x is equal to r times the cosine of a. And so this is all related to where we are, you know, for these circles. So pi is significant here, and 2 pi, to try and give us some math based formulas that will follow kind of the ellipse circle shape. So I'm going to say let y equals r times the sine of a. And I'm going to pass into the vertex, instead of hard-coded values, I will say x and y. So we have a really neat looking little splatter here. Pretty tiny, so I think we need to maybe make r a little bigger. So I'm going to say r 200 times the cosine. Whoa, that is so cool.
That is.
It looks like an eyeball, like an iris.
Or like a dandelion.
Uh-huh. Yeah, so it's black. What if I made it yellow? Or like, is goldenrod
I think it
color?
is.
Yeah, there we go. That looks pretty awesome. Like, we've created art, and this has pulled me out of my, like, I don't know if I can do math feeling. You can do math. I'm doing math. And
Heck
P5, yeah, heck yeah. I mean, it's really never too late to dust those skills back off. And there are so much information on YouTube I found in looking into this. So it's pretty exciting to rekindle that love with math and make art out of it. I mean, art and nature, like this totally looks like something you would find in nature. And that is nerdy, but I love it. Okay, so I passed this hard-coded value here of 30, and that made this one design. But if I wanted to make this more dynamic, I could use a variable instead, and maybe I could use a little slider to use some user input to define how these ellipses are being drawn. So I'm going to start back up at the top. I'm going to set some variables. P5 gives you some user interface stuff for free. You have to do a little bit of massaging to make it more accessible, but I will start with a variable for slider. And I'm putting it outside of these two functions so that I can call it from within either setup or within draw. So sort of hoisting it, making it available to both of those functions, because otherwise, if I defined slider inside of setup, then inside of draw, it wouldn't know about it. It'd be like, what's the slider thing? Because the scope of it would be too, you know, it would be abstracted away in the setup function. So by hoisting it up here outside of both functions, it puts it in the global scope, so I can call it from wherever I want. So inside of setup, I am going to say slider equals create slider, and this is a P5 method. It used to be part of a separate DOM library, but now they include it straight in P5. And I'm going to make it a slider from 1 to 10. Those are the values. I'm going to start it at 4 in the middle, and I'm going to make it increment by 0.1. So on the page now, I have this little slider. It's not really doing anything, but I can drag it around. I am going to give the slider a label using the P5 attribute function, and I'm going to give it an aria label, and I'll just say adjust drawing maybe. I mean, it's really just because without any sort of label, be like, what is this slider for? I don't know. Even though, sure, it's manipulating a visual art piece, but you know, we can do our little bits of parts to make something more programmatically like explain what it does. So we've added this label here. We need to hook this up to something. We actually need to, instead of this 30 number down here, let's make another variable up here and call it K. So I'm going to say K. And so depending on, you can see my code, it kind of made it, when I have a syntax error, which is like an unfinished expression here, the code just kind of goes, eh. Let's see, so the two numbers that we have in here, it is the numerator and denominator. This comes from this math. So there are all of these different patterns here. So these curves, these all have different math. And because these are circle ratios, the numerator and denominator here, this n over d, are significant for what pattern you end up creating. So I'm just picking two values to start here of 5 and 8, but they are related to these shapes that we want to create. So now instead of 30, I'm going to put K in here to pass that.
That's super cool.
Yeah, right? Isn't that neat? Like, I mean, you can you don't have to fully understand this math to play with it. And I think that is the most freeing thing. Like if in high school I had been able to play with this, that might have changed my personal relationship with math because it's visual. And I just think this is so neat. So we've got this variable coming in here. And if we want this slider to manipulate that, we could start off by saying, let's see. So in our draw function, outside of the loop, I'm gonna reset K in here to say K equals slider.value. And it was starting off at 4, so that initial ratio here of 5 over 8, if I just hard coded that to whatever number our slider is at, that'll be the result of this division here of 5 over 8. That is being replaced now with whatever value our slider is coming up with, which is a single number. Because we're incrementing by 0.1, it can be a fraction. It's not necessarily a whole number or whole integer. But let's see, if I wanted to, so I've actually got this changing based on when I drag this slider around, and I can put my keyboard here and should be able to, wrong part of the window. These little inputs, when you get your focus onto them, you can kind of use your arrow keys to drag around, which is really neat. What I wanted to show you was if I turn things off, like start playing with this script, like if I turn the background color, the background of white off, you can see how each of these flowers, when they're sort of not cleared, they layer on top of each other, which is a cool effect. Like that almost looks like a silver dollar that you would find on the beach.
Mm-hmm. Yeah, exactly.
How it's got these kind of lines, and I think the color plays into that too. But I love how, you play with these different things, turning things on and off, and all of a sudden you see things that you might see out in nature, and that is just awesome. I'm going to turn that background back on to make it more like this rose art. And I've got it hard-coded here with goldenrod as a color, but I thought it would be really neat if we made that color random instead, so that when you drag it around, the color changes. So let's start. I have to pick a color to start, and I can't really use the named colors for this. It's a lot easier if I use a different color space like hexadecimal, for example. And let's say starting color, I'm going to give it a string and a color. Let's see. I mean, we talked about earlier, like black was 0. So it's hexadecimal is typically 6 numbers, sometimes 8 if you have some transparency in there for an alpha channel. Typically when you see a hexadecimal color, it is the hash symbol and then 6 numbers. I am going to play with these without the hash and just the raw numbers, which means I can manipulate them with math functions. I'm going to pick something a little more interesting than black. We saw earlier there was a number for white that was 255. In hexadecimal, that is all Fs, F for fun. But white wouldn't really show up either. So I'm going to pick a random color of A34FFF, and that gives me pretty close to that goldenrod color, actually. I did not even mean for that to happen. I just picked this random color. So if I wanted to use a different stroke color, I have that color value up there of starting color A34FFF. So I could say starting color, but it still needs that hash symbol to actually be a valid hexadecimal color. So I'm going to use what's called string literals, where I can put in, using backticks, I can combine strings with some variables. So this starting color is a variable. I'm sort of escaping outside of this string using a $ and curly braces to wrap the dynamic part. And actually that color was not goldenrod. I still had that hard coded. It is a purple color. That was a little too much of a coincidence.
Yeah. And so since you had that, since you called that stroke function and you still had your hard coded value, we got our goldenrod flower, and it only appeared because we were still seeing that refresh every time we change the code. It looks like something happened. It looks like something happens every time they change something.
Yeah, and every time that I make a change in the script, Glitch is also re-rendering, everything. So there is that aspect. To make this a little easier to follow, I'll show you what this hexadecimal color, if I just wanted to hard code this purple color, this is what P5 is expecting. So this, I'm using backticks, but this could be a string as well, which uses just like regular quotes. If I want to replace just these numbers with a variable like our starting color, that's where that string literal comes in, where I need these backticks. The hash symbol is still a string, but I need to escape the dynamic part. So I am going to, inside of these quotes, I will say, or backticks, starting color. So that replaces just the number part, and the hash symbol is still in a string format. And that way, when JavaScript runs this code, this more modern version of JavaScript, there are older browsers where you would need to compile this to something else. And even just to show you another way of doing this, I could use regular strings and just sort of exit, use a plus sign, and this is essentially the same. So this combines the string hash symbol with the variable starting color. Maybe I'll just leave it like that. It is sort of an exercise in there's multiple ways to write something in JavaScript, and it's sort of finding whatever makes the most sense to you, whatever you can wrap your mind around. And sometimes simpler is better. So let's go with that. So we've got a starting color. If I wanted that to be more dynamic, though, I need some sort of a function to generate a random color. So I've got a starting color. If I wanted to update it based on the slider, I could add a function so that whenever the slider value changes, it generates a new color. So how about slider dot input? So because we're using the slider from P5, it gives us this input function that we can call. And I'm going to pass it a new function I'm going to write called update color. And this one I could call whatever I want. It's because I'm calling it here and then I'm defining it myself, I can write custom things as opposed to like create slider, that's a P5 function. And setup is a P5 function, but I don't actually have to call it. Update color, on the other hand, is one that I'm both defining and calling. So inside of update color, I'm going to say, I'm actually going to change this to random color. And then random color will be down here. And so in here, I'm going to override random color. Whenever the input changes, I will use some functions. I'm going to use some parentheses here to group things. So JavaScript gives you some math functions by default, which is pretty cool. So this math object here, let's actually hold our horses here and go and log console.log math, because we can log anything in JavaScript and go and see what does that give us in the browser. And JavaScript math, you know, and I mean, like time and clocks in JavaScript, they might not be super exact, but they're still useful. So here, if I drag this slider, I'm getting this math function or math object, and it comes with different things. So it gives us pi. This is probably what P5 is leveraging. There are functions here, like getting the ceiling of something or the floor of something, so either rounding up or rounding down. Sometimes you need these to make sure that you have whole numbers, which is what we're going to use it for. So I'm going to say random color math.floor to round down. I'm then going to get the rounded down value of math.random, which will give me a random number value. And I'm going to multiply it by a pretty magic number of 167,215. And I believe this maps to the like color space, like how many available colors there are. And then on the outside of these parentheses, I'm going to say toString, and I'm going to pass it 16. And that is a super hack to convert this random number that JavaScript can give us within bounds, rounded down to the hexadecimal color space. So if I say random color, and I open our DevTools again, and I drag the slider, it's giving me these numbers and letters that look pretty darn close to hexadecimal values. And because it doesn't have a little hash on the front, so that's where adding it in here with this kind of combination of a string and a variable. And it's actually because I have used this random color value variable and I'm overriding it whenever I draw the slider, this actually already worked. So I can get from really neat greens and pinks and sort of like all over the place with these random colors. And I'm doing this when I drag the slider. So a bit of a warning with animated things, like this could really give someone a seizure or like make them ill. So you want to be careful with like automatically generating this kind of thing. But I'm doing this on user input. So dragging the slider, you know, maybe I could add a warning of like, hey, this flashes colors and shapes, because it can be a bit of a safety issue. But we're playing with it. We're, you know, using this in a safe space in a safe way. And so that is pretty darn cool what we were able to do with P5. Let's see, was there anything else that we could do with this? I think really playing with all the different colors, playing with sizes and values. I mean, if I wanted to change this, like make this not quite as big, I can multiply it by 100 instead of 200, and you can see the lines don't go out quite as far to the edge. But we can play with all kinds of things, like maybe I make this 2 pi times 10 instead. That doesn't really seem to change anything. So maybe that part doesn't matter as much. But changing the radius and kind of the different parameters that we feed into creating these X and Y coordinates, pretty rad.
Stroke weight, change that too.
Oh yeah. Yeah, and so I did change one thing of the background, and it actually changed the background of the whole canvas. So we were seeing it, you know, either turning it on and off, like either it's replacing it with white or not. But I could play with this more, like maybe the background has a random color. I'll change that in a second. Let's do the stroke weight. Stroke weight could be like 10. I mean, we could change that a lot. And yeah, that changes it quite a bit. I'm gonna give this a random color on the background too and see what happens there. Whoa. That is so cool.
That is cool.
Oh my gosh, I love it. I could play with this all day. And you could do so much more with P5. I mean, this is like one one dimension of what we could do. I mean, literally, it's 2D. But it could be 3D. You know, we could pick other math. We could go create something closer to the Inspirograph. But I think it's interesting to see kind of how this stuff is done. Like, even though we're not going all the way to a spirograph, we got some of the same characteristics and some of the same math within, I mean, we're not even at the top of the hour yet. So P5 can get you going with this type of art pretty fast. And there's so many resources out there to help you kind of get started with the math, and just playing with it and seeing which, you know, if you pull these levers and change different things, how does that change what your art looks like? I mean, we could make the stroke width be random. That could be kind of cool. Like maybe, let's see, random color. I mean, I could change the name of this to, instead of update color, it could be update design. And then I can do other things, like maybe I give a random stroke weight. Random stroke weight, we could make it 1 to start. My semicolons here. So let's say if I did random stroke weight, and I'm gonna use similar math, math.floor, then I'll get math.random. Let's see, so the max numbers, gosh, I don't know, what does the stroke weight go up to? Let's go look. Because that sort of tells us what, you know, what do we need to do to actually make this work. I mean, I would think 100 probably, a weight in pixels of the stroke.
Yeah, so after a certain point, you just won't notice a difference.
Yeah, well, I think it would just like, the stroke would just get so big that you wouldn't see it. So maybe like between 1 and 10, maybe.
Yeah, sounds great.
And I haven't done this before, so we'll see if this even works. But like, let's see, random stroke weight. And this is true playing here. Yeah, that seemed to do something.
Yeah.
I didn't do the 2 string on the end. So that got us, the 2 string got us, you know, within 16, that's actually changing kind of the base numbers to get it into that hexadecimal. We don't really need hexadecimal. We just need like single numbers between 1 and 10. But that seemed to work. I guess we could change the background color maybe to back to white to see it a little bit better and see our random stroke color or stroke weight. Yeah, that worked. Oh, that is so cool. Neat. I guess one issue is, so our canvas, with how big this radius is, it sort of gets cut off because the stroke now is making it wider. You know, every I guess they're pixels and how they're being rendered on the screen, but these all do add up in a Cartesian coordinate space where it became a little too big. So I could lower this radius size to be 180, and then maybe it won't actually get clipped by the size of the canvas.
Yeah. And Scrabble points out that you could add a toggle or something. You could use different user inputs to create a tool where anyone can make art with this same kind of setup.
Totally. Yeah, you could make like an art site. Well, and there's more to the math here. Like the example that I looked at actually went further and made 2 sliders for this ratio that we sort of just picked a single, you know, we have 5 and 8 here for the numerator and denominator. But we ended up just using a single number, kind of the result of that math equation. So yeah, you could use different sliders for that. You could make, you know, all kinds of different levers. I mean, that's what Inspirograph does. It's got all these different wheel sizes, you know, with the gears and the teeth, those can make different values. Depending on where you would put your pen in the Spirograph could make different values. So yeah, I think there's creating the art for yourself to play on a website, and then there's creating the tool for other people to make art. And it's really, the sky's the limit. You can do all kinds of creative things. And maybe you even create some art and print it out, or create something with a spirograph and then try to recreate it with code, even using the InspiroGraph interface. So we'd love to hear, if you end up playing with this, playing with P5, and you come up with some examples or, treatments to add to a bigger website, definitely let us know, because we love hearing sort of what this inspires you to do. And I know for myself, I'll probably be doing some more math. Sweet. Well, yeah, we've got 5 minutes left. If anybody's got any questions or different levers they think we should pull to play with these different designs. I can see, sort of depending on where the slider is, the numbers don't quite add up. So like, you think of the spirograph, if your pen doesn't make it all the way back, when you're drawing it in real life, you just sort of, the line ends. But when you're creating it with vertices, and how we had this begin shape, end shape, they have to connect. So if the math doesn't quite add up, that's where you see these kind of random lines going through here. It still looks cool. So, I mean, it almost looks like snowflakes, in the winter when you cut out paper and then, you fold it and create those little snowflake patterns. But the lines not being completed, that is due to the math kind of not adding up to, so that the vertices, they have to connect somehow. So they sort of just like dynamically draw across the screen. So some kind of unique quirks between real life drawing and creating it with math on a screen. I think that's pretty cool.
For sure.
Awesome. Well, next week we are going to play more with JavaScript, and actually creating, using JavaScript to go and fetch resources. So creating something that maybe goes and hits, the NASA image API, or there's one with dog images, and there's all different kinds of APIs. There's, Flickr is another one. And those are sites and applications that you can go and request data, and then you can display it in your web page. So next week, we're going to be playing with going and fetching some data and displaying it and then doing things with it. So that's where we're going next week. And that's all I got for this week. So thanks for tuning in to Gatsby Web Creators.
Yeah, thanks everybody, and thank you to our captioner Joanna. And if you're not already following the Gatsby Twitch channel, now is a great time to do that. And thank you, Marcy and Aisha, and we'll see y'all next week.
See ya. Thanks for coming.